you ever thought that setting up a cloud database is complicated? Or that connecting a microservice to a professional NoSQL cluster requires advanced skills? Today, I will show you that it is much easier than you think. Welcome to Microservices in the Cloud with Jay, where we explore the world of microservices, cloud computing, and modern IT architecture. In this episode, we will go step by step from creating a MongoDB Atlas cluster on AWS to configuring access and finally, connecting our Orders API microservice to the cloud database. You will learn how to choose the right region, set up security, and make sure everything runs smoothly. Sounds good? Let's get started. First things first, log in to MongoDB Atlas. If you do not have an account yet, no worries. It is free and quick to create one. You can even sign up using Google, which is what I am doing here. Once you are in, you will need to accept the privacy policy and terms of service. Just check the box, hit submit, and you are good to go. Now, you will see a setup screen. This is just to personalize your experience based on your preferences and project type. You can select whatever applies to you, or just do what I did and move forward. Now we are on the Deploy Your Cluster screen. This is where we choose a cluster tier. We have got three options. M10, which is a dedicated cluster for development with more storage and better performance. Flex, which is ideal if your traffic varies since it can scale up dynamically. Free, which is great for testing, learning, and small-scale projects. For this tutorial, I am taking the free tier. It is quick to set up, completely free, and perfect for what we need. Next, we choose a cloud provider. MongoDB Atlas does not have its own data centers. It runs on AWS, Google Cloud, and Microsoft Azure. So when we pick a provider, we are actually deciding where our data will be physically stored. If your users or servers are in the USA, choosing a region like Oregon AWS will help reduce latency and improve performance. Also, depending on regulations like CCPA in California or GDPR in the EU, you may need to store your data in a specific region. Now, let's configure our cluster. By default, MongoDB names it Cluster 0. But since we cannot change this later, I will name mine Cloud with JCluster. It is always good to have a meaningful name that reflects its purpose. One thing to note, pricing varies across regions for paid plans, but for the free tier, it does not matter which region you pick. It is free no matter what. So, I will stick with AWS in Oregon. Now, before we create the cluster, let's check the quick setup options. Automate security setup, we will leave this enabled to keep things secure. Preload sample dataset, this lets us load some example data, which can be useful for testing. Everything looks good, so let's create the cluster and move on to the connection step. Now that the cluster is ready, we need to set up a database user and define access rules. By default, MongoDB Atlas detects your IP address and adds it to the access list, so only your machine can connect. If you need to allow more IP addresses later, you can do that in the network access settings. Next, we set up a database user. MongoDB generates a username and password for you automatically. This user has Atlas admin permissions, meaning full access to the database. Make sure you copy the password and save it somewhere safe. You will need it later, and MongoDB will not show it again. If you want, you can also set a custom username and password. Once that is done, click Create Database User, and now we are ready to connect. Let's talk about connecting your application to the database. If you were using MongoDB's Java driver directly, you would need to select Java and pick an API version. But since we are using Spring Boot with Spring Data MongoDB, we do not need to worry about this step. Spring handles it for us automatically. The most important thing here is the connection string. This is what your app will use to connect to the cluster. Copy this string and keep it secure. It contains your username and password, and MongoDB will not show the password again after you close this window. In a moment, we will add this string to our Spring Boot configuration. First, let's update our orders API project to support multiple environments. I will rename the base config file to application local YAML. This will be used when running the service locally. Then, I will create application Atlas YAML, which will contain our MongoDB Atlas connection settings. To maintain clarity, I'll place shared settings into the main application YAML, ensuring it's loaded for all profiles. Finally, I will paste the connection string into application Atlas YAML, so Spring Data knows where to connect when we start the service with the Atlas profile. If you just paste the connection string as is, it will not include a database name. That means when we start the service, we will get an error. Database must not be empty. To fix this, we need to add our database name inside the connection string. I will insert orders DB between the slash and the question mark. And now we are good to go. With the correct connection string in place, I will start the service. Remember that to start the service with the database configuration defined in the application Atlas YAML file, you need to set the active profile to Atlas before launching it. I also started the Payments API beforehand to make sure everything runs smoothly. Now let's test it. I will send a request from Swagger, just like we have done before. If everything works, our data should be saved in MongoDB Atlas. Alright, let's open up Studio 3T and set up a connection to our Atlas database. We're doing this to check if the request data actually got saved. In the new connection window, I'll just paste in the connection string. This version doesn't include database details. I just need to get access to my database server. Next, I'll name the connection the same way I did for the local setup. So, I'll call it MongoDB Atlas. I'm not changing anything else, closing the window and clicking Connect. Once we're connected, on the left side, we'll see all available databases, including the preloaded sample dataset that came with Atlas. It's actually quite a big set of data, which can be useful for testing. And as you can see, our orders DB database is there too, with the orders collection inside. Now, this is a great example of one of MongoDB's biggest advantages. Since it's a NoSQL database, there's no need to define a schema. Collections and documents are automatically created as soon as data is inserted. That's why the orders collection is already available. We didn't have to set up anything manually, just pushed some data through Swagger. You can also browse the data in different ways. By default, it's in table view, but you can switch to tree view or JSON view if you prefer. Everything looks great, which means our orders API is now successfully connected to MongoDB Atlas. To wrap things up, let's go back to the Atlas Cloud page, where we previously configured the connection string and other connection properties. On this page, we have access to the Browse Connections option. After clicking it, a preview of the databases on the Atlas server appears. On one hand, this serves as a database client, which can be very useful if you need to check something in the database, but don't have access to your computer at the moment. On the other hand, it's a powerful tool that allows for much more than just browsing data. One of the key tabs in Atlas is Overview, which provides a high-level summary of your cluster, including details about your nodes, region, and key metrics such as storage usage, number of connections, and read-write operations. In addition to this, Atlas offers several other important tabs for performance monitoring and optimization. The Metrics tab helps track resource usage and system performance over time, making it easier to identify bottlenecks. The Performance Advisor analyzes queries and suggests optimizations, such as adding indexes, to improve efficiency. Meanwhile, the Real-Time tab provides live insights into database activity, which is invaluable for debugging and monitoring operations as they happen. However, it's important to note that both Performance Advisor and Real-Time Performance Panel are not available in the free tier M0 or shared clusters M2, M5. These features require an M10 or higher cluster. So, there you have it. Setting up a cloud database and connecting a microservice isn't as complicated as it might seem. We started by creating a MongoDB Atlas cluster, choosing the right region, and setting up security. Then, we configured database access, created a database user, and generated a connection string. We integrated everything into Spring Boot, ensuring multiple environments work smoothly. Finally, we tested the connection, verified the data, and confirmed that our Orders API is successfully connected to MongoDB Atlas. By following these steps, you now have a fully functional cloud database for your microservice, running securely and efficiently. If you found this video helpful, don't forget to like, subscribe, and hit the notification bell so you won't miss future episodes on microservices in the cloud with Jay. Let me know in the comments if you have any questions or if there's anything specific you'd like me to cover next. See you in the next episode.